Ugly. A lot of people think this is okay. Not me. Drives me insane. So, how do we solve this? This is the stock piece. You'll notice it's the F piece. 12 volts. Single wire is what runs the show on a stock machine. This is the stock piece. And yeah, you just drop 12 volts on it and you call it a day. That's cool, and that works for a lot of people, but where we're going is you're looking at a heavily modified machine. You'll notice this is still a work in progress. Probably wondering why. That's why. This is a 12 volt LCD marquee that is going to take the place of the stock marquee. So it's going to be illuminated and it's going to be awesome. Okay, so 12 volt, 5 volt for the illuminated controls, 12 volt for the cup holders, 12 volt for the monitor and the speakers, and then 12 volt for the LCD marquee. The other 5 volt is behind, and that's actually the microcontroller that's running. Now the cool thing is what you're looking at right now is actually 12 volts being stepped down to 5 volts. So I really thought I was gonna have to make some PCBs, sell them for like, I don't know, $5 or something on Etsy and make my millions for all 3 people that buy. Sounded difficult, although it would be a great learning lesson, but it's something that instead I will show you the way that I went. So this is the bench power supply that I use for testing. Lets me change from a variety of voltages and current. If you've never seen one, that's what it does. And then you've got your connectors that you use right there. This is what is making the magic happen. So we're looking at 12 volts is going in here. With no load, this thing is normally at 5 volts. Right now we're looking at 4.97 volts with 800 and let's call it 30. Say 850 milliamps. And that is our output right there. So that's 5 volts, and then we're looking at 0.83 amps, so 830 milliamps. And then we are going to a barrel jack right there, and then the barrel jack to a dumb USB-C, which is then going to the 5 volt microcontroller. The microcontroller has a range of 5%, so it can go 4.75 volts or between 4.75 volts to 5.25 volts. 5 volts dead on is ideal. 3 amps is what we're looking for, trying to follow the specifications from the Raspberry Pi Foundation. So that is what we're set to, is to cover that. This is behind the scenes. This is 12 volt right there. That's 12 volt right there. Somewhere in there is where the 5 volts is. And then also deep in there is the 12 volts for the cup holders. And then there's going to be another 12 volts that is running up to there for the marquee, for the LCD marquee. So it's still a work in progress. And then it's from there it's going to be just cleaning up the wires. So anyways, yep, that's about this weekend's update. 12 volts right here to 5 volts to there. And then I'm next going to be working on splitting out from here to not only the microcontroller, but also to the illuminated controls. And then that's it. I'm done with the 5 volt part of the equation from the 12 volts inlet. And then I will focus on adding in 12 volts for the LCD marquee that goes up here. And then that's going to be how I have just a single wire that runs in and runs everything. So we take the highest voltage, which is 12 volts, and then work our way backwards. And so this is, if you Google, I will be including this in the article, but this is buck shifting is how we're doing it. So yeah, if you want to learn about it, you can just Google buck shift. There are some really great tutorials on if you want to do your own buck shifting of voltage and build your own circuit on a PCB. And yeah, definitely I will try to link those as well, since that's actually what I thought I was going to have to do originally, especially because I'm trying to throw so much current. Right now I'm looking at 5 volts and 6 amps, and there was not much that can handle it. This piece is one of the very few that could, and thankfully it appears to be working. No magic smoke has been released from any of the electronic devices. So yeah, everything is great. So now next up is going to be, like I said, splitting off this for the illuminated controls, and then continuing to split the 12 volts where I can sit there and cover everything that requires it. I'll probably use a terminal block. I think that might be one of the ways to go. Or if I don't go for a terminal block, then I'll see if I can find like some kind of CCTV barrel jack splitter that's able to sit here and take all these splits.